Hello, future doctors. Welcome to the sixth episode of our Neet chemistry series for 2025 and 2026. I'm your mentor, Jongtam David, and today we're diving into one of the most vital and conceptual chapters, which is your general organic chemistry. We'll tackle 45 handpicked questions that will help you build a rock solid base and boost your accuracy in reaction based problems. GOC isn't just theory, it's the language of organic reactions. So master it and you unlock half the battle in organic chemistry. And remember this, success doesn't come from what you do occasionally, it comes from what you do consistently. So stay with me, stay consistent, and let's crack together. Now, without further ado, let's dive into the questions. I'll read out the first question for you. You can also start thinking for the answer. Great. Let's move. The correct decreasing order of priority for the functional groups of organic compounds in the IUPAC system of nomenclature is. So these are various types of functional groups. You know what is functional group? These are atom or group of atoms that determines, that characterize the property of the organic compound. You are given different functional groups here: carboxylic acid, sulfonic acid, amide, and a carbonyl compound, aldehyde. So this is very fundamental point which you have been learning in your class 11 NCRTs. It's there in your NCRT textbook. You can refer to it. So when you do the arrangement, the priority for the functional group, the most priority according to the priority sequence, carboxylic acid comes first. The second ranking is your sulfonic acid. Third will be your amide, followed by the carbonyl group, aldehyde. So find the answer from these options available. You can see it's there in question option A. So answer for question 1 will be option A. I hope it's clear. Let's see question number 2. The IUPAC name of the compound which is given here in the screen, as you can see, you have to name this compound given by the nomenclature according to IUPAC. So when this aldehyde is treated as a side chain, its name is called carbaldehyde. You have to keep this in mind. Carbaldehyde is the name when aldehyde group is treated as a side chain. And when this aldehyde is treated as a functional group, it is called ALL or aldehyde. Okay, so this is in bond line notation. I will write it down for you, the expanded form of the given compound. CH2, CH2, CH2. So this must be the expanded structure of this given bond line notation. Now the longest carbon is the parent chain. Yes. So when you do the counting, you can either start left side or right side. Now, when you do the counting from the, okay, I'm doing the counting from the left side to the right side. So the name for this compound will be called 1, 2, 3 tricarbaldehyde. Okay. For question number 2, answer is propane 1, 2, 3 carbaldehyde. Question number 2, option B is the correct answer. I hope this is clear for all of you. Let's see question number 3. I think this is already repeated. If you are watching my previous episode 1, the not episode 1, episode 2 in alcohol, phenols, and ethers, you will be noticing that this question is repeated. Okay, the options are given only A and B here. For your reference, I will show you the second, the third, and the fourth option. Yes. So question is asking which one is the correct formula of vinyl carbinol. As you know, vinyl carbinol is methyl alcohol, and hence methyl alcohol will be option 1, okay, or A. This is the answer for question number 3. Let's move on to question number 4. The compound given to you is known by which of the following name? So this is a bicyclo compound. In the nomenclature part for Neet exam, sometimes bicyclo compounds are asked. So you have to prepare this thoroughly. So this name is given bicyclo. It will be 2,2,2 octane. The answer for question number 4 will be option A. This is the answer to question number 4. Let's see question number 5. The stability of the compounds are given to you. 1, 2, 3, 4. Find it out. So how to find the stability of any organic compound? But given to you here is cyclohexane. As you can see from option number 4, it is a non-planar. Sometimes it has a chair conformation, and in this conformation the bond angle is the normal tetrahedral angle. You know, tetrahedral angle is 109 degree 28 minutes, and it has no angle strain, okay, and hence this will be the most stable, which I've shown you here. Cyclohexane, this will be the most stable. Let us give the ranking here so that we can easily note it down later on, right? And the rest of the molecules, they are nearly planar, and hence their stability depends upon the angle strength. So in accordance with the theory, I think you have learned one theory in your class 11 standard, Bayes strain theory, right? So since this cyclopropane has higher angle strain, so how to find this angle strain? There is a formula. Let us write it down. The angle strain will be 109 degree 28 for tetrahedral bond angle, 60. Subtract it from this 109 degree 28 minutes and divided by 2. The answer will be 24 degree. Yes, subtract it, 60, 28. It will be 44 minute. Then this is your angle strain in your cyclopropane. Okay, I'm calculating for option number 3. And for cyclopentane, sorry, this is for cyclopropane. So cyclopropane will be this one. And for cyclopentane, you can easily calculate the Bayes strain theory. According to Bayes strain theory, the angle strain will be 109 degree 28. You have to subtract this bond angle 108 degree divided by 2. You will be getting the answer 0 degree 44 minutes. So from this value, it is evident that cyclopentane 3 is more stable than cyclopropane 1. Okay, so give the ranking 4, 3, 1. This will be 2, and definitely this will be the least. Okay, so because of the presence of double bond in this 3-membered ring, cyclopropene, okay, this will be the least stable. Now if you make the arrangement in sequence, this will be as you can see from the screen, I have marked it 1, 2, 3. So compare it, 4 followed by 3, 1 and 2. So 4, 3, 1, 2 will be option A. Correct. Option A is the answer to question number 5. Let's move on to question number 6. The fractional distillation is used when you read the statements. There is a large difference in the boiling point of liquids. B, there is a small difference in the boiling point of liquids. Boiling point of liquids are same. And liquid form constant boiling mixture. This is your azeotrops. Okay, if you know what is distillation, you can answer this question easily. See, if there is a small difference of boiling point, let us say 10 or less Kelvin, in the boiling point of liquid, fractional distillation is used. Remember this. For example, acetone will have a boiling point of 333 Kelvin. Methanol will have a boiling point of 338. So roughly 5 or 6 Kelvin is the difference in the boiling point of the two. liquid mixture which I've just mentioned, that is acetone and methanol. Right, so if there is a small difference in the boiling point 10 or less, we use fractional distillation. Even in petroleum industry, for refining petroleum, this fractional distillation is used. This can be your side knowledge. Okay, anyway, to answer the question number 6, the correct option will be B. I hope this is clear for all of you. Good. Let's see question number 7. The rate of the reaction is the fastest when Z is the leaving group. This is your nucleophile. See, chloride is the best leaving group, remember, among the given options. Okay, here, option C. You know the reason? Because it has the high electronegativity value, and thereby it generates positive charge on the carbonyl carbon atom. So question number 7, it's easy. I hope everyone can answer this based on the electronegativity. This will be the answer. Z will be chloride, and it will be the fastest when Z is replaced by chloride. Clear? Okay, moving on to question number 8. The order of activity of the various ortho and para director is. Okay, you're given different types of functional groups here. Okay, if this, let us say O minus, suppose if this is present in the phenyl ring, it becomes a phenoxide ion. Okay, for general understanding, I'm writing the structure here minus. You know how many lone pairs are there? You should know how to write the Lewis structure. Okay, so the most electron releasing tendency will be shown by phenoxide because it has a negative charge on this oxygen. Electron releasing tendency. We call it ERG in short. This is your phenoxide ion. This will be much greater than phenol, okay? Because phenol doesn't have any negative charge. However, it still has lone pair of electron. And again, this phenol will be greater in comparison with this ester. Okay, let me write it here. I'm struggling here to write the pen, so excuse me for that. Carbon, double bond, oxygen. This is your ester. So it has a less electron releasing tendency. Why? Due to the presence of this carbonyl group. It shows resonance with the electrons on the oxygen atom. And the last will be definitely your acetophenone. Okay, so when you do this comparison, you will definitely get the answer. Question number 8 will be A. Okay, easy. Question number 9, the general formula of this hydrocarbon could be for open chain. You have two oxygen, and this is the general formula of alkene, right? So when two oxygen is attached, you know this is your carboxylic acid, the general formula of carboxylic acid. Very good. Then let us see the next question. Yes, you are given an aldehyde. Can you name this aldehyde? It's your benzaldehyde reacts with hydrogen cyanide. It gives cyanohydrin. Okay. So since this, during this reaction, you know, a chiral carbon is created, and further, this cyanide ion can attack the planar aldehyde group either from the top or from the bottom face of the aldehyde group with equal ease. Okay, so therefore 50-50 mixture, racemic mixture, you can call it enantiomers, will be obtained. Okay, so question number 10, answer will be A. Racemate, or you can say 50-50 mixture of enantiomer product, that is racemization takes place, racemic mixture is obtained. Moving on to next question number 11. Let us read the number of possible open chain for the molecular formula C5H10, it may be pentene, would be. See, C5H10 has 1 degree of unsaturation, that is alkene, right? Since the isomers are acyclic, all of these are going to be alkenes. And for writing the isomers, you cannot have a cycloproduct, okay? So where for writing the isomers, first introduce a double bond at different possible positions and then consider the possibility of branching the alkyl group. This is a 10 standard question. Okay, question is not asking you for closed structure, only open structure. Okay, so when you find out all the possible structure, you will get the answer. With the formula C5H10 means initially you have the normal one, that is pentene, CH2, CH2, CH. This is your normal pentene. Okay, we can call it 1-pentene. And subsequently, let us jump this double bond to the second carbon. The name will be called pentuine, or you can say pen-2-pentene. It can have cis and trans isomer. Remember. Then next possible isomer will be. Let us now do the branching part. All right. See, we are just hunting for the possibility. Okay, the probable product with a given set of formula. CH3. Yes. Can you draw some more possible structure with the formula C5H10? Remember, question is directing you only the open structure. So you have to read the question thoroughly, follow the instructions. You know what is important in exam is you have to follow the instructions. Okay, first you have 1-pentene, second you have 2-pentene, cis and trans isomer is possible in the second isomer. 3 you have 3-methyl-1-butene, 4 you have 2-methyl-1-butene, and the fifth is 2-methyl-2-butene. So how many possible isomers are generated? You have 1, 2, 3, 4. Okay, since I have told you before, this one, pen to in has two possible isomers. You can generate two more. You can draw cis and trans. So counting this cis and trans, you have 1, 2, 3, 4, 5, 6 isomer. So answer will be 6. Clear? Yes. You know, cis and trans is geometrical isomer. We'll see question number 12. Which of the following is the stablest structure of cyclohexatriene? Okay, cyclohexatriene. What is cyclohexatriene? Yes, it is your benzene. Okay, benzene is the common name of the IUPAC name cyclohexatriene. So since all the 6 carbon atoms of cyclohexatriene, benzene, these are all sp2 hybridized, therefore it is the most stable structure in the planar form. Okay, not the board form, not the half chair form, not the chair form. Configuration is stable in case of planar form because all the carbon are sp2 hybridized. Let us see question number 13. The compound that is formed in the positive test for nitrogen with the lysine extract solution of an organic compound is. This is theory question, very simple. You should know how to make this lysine extract. See, it gives Prussian blue. A very nice color is formed. The formula of that Prussian blue will be a coordination compound. So when this sodium extract hexacyano, sodium hexacyano iron complex treated with the ferric salt, it gives a very nice violet blue color, which is also known as Prussian blue. Okay, so question is asking what is the formula of that organic compound? 3 plus and 12 moles of sodium ion. So answer for this question number 13 will be A. This is your Prussian blue color. Question number 14, 2 point. This will be in the category of quantitative analysis. Okay, so you have to find the percentage of phosphorus, right? Read the question. 2.79 gram of an organic compound when heated with Curie's tube and the concentrated nitric acid, phosphoric acid, it forms and converted into a precipitate. The precipitate, magnesium precipitate on heating gives 1.332 gram magnesium compound. Percentage of the phosphorus in the compound is. So what is the formula you can use? to find the percentage of phosphorus. Yes, it is 62 divided by triple two into, these are important questions for your NEET exam, P2O7. This is the form product divided by the given weight of the compound. So use this relation and you can easily answer the question. What is the answer for this? Let us see. 62. I will write at the bottom because we don't have space. Okay. Percentage of phosphorus will be, I'll write here, equal to 62 by triple two. The given weight of the magnesium oxide is 1.332 divided by compound has weight 2.79 into 100. Okay. So you can calculate this and give the answer. The answer will be approximately 13.33 percentage. B is the answer for question number 14. Question number 15, match the column. So I will show you the next screen. It is not showing up. Okay, question number 15 is incomplete. Let us write the points here. Diethyl ether, D methyl propyl ether, D dimethyl ether, and ethanol. In option 3, you have position isomer. Option number 4, chain. So match these two columns. The first one, you have acetic acid, 15. So the options are not available here. Anyway, let us see. A will be, these are functional isomers, 1 butene and 2 butene. This will be position isomers. It differs with respect to the double bond. Diethyl ether and methyl propyl ether. C will be metamer. Dimethyl ether and ethanol. D will be chain isomers. Okay, question number 16. 15 was incomplete. 16, yes. The accepted IUPAC name of camphor, this is the formula of camphor, will be 177 trimethyl bicyclo 221 heptane 2 on, or is it heptane 2 on, heptane 6 on, none of this. So what will be the answer to this question? It is a bridge compound. So when bridge compounds are given, you can do the numbering 1, 2, 3, 4, 5, 6. Then later on here, 7. So how to name this? 1, 7, 7. So you have two substituents here, three substituents here, methyl as a substituent, 177 trimethyl. Since this is a bridge compound, it will be called bicyclo. And now you have this 2, 2, 1. In this position, 2, 2, 1. Then count the number of the parent chain. It has 7 carbons. So heptane 2 on. Clear? So answer for question number 16 will be A. Question number 17. The pair of structures given below represents enantiomers, diastereomers, structural isomers, two molecules of the same compound. So which of this is the correct answer? You can convert this into the Newman projection. Okay, into this Newman projection is can be converted to open chain structure. So how to convert this to the open chain structure? I'll write it here. Okay, chlorine, hydrogen. This is the Fischer structure of the given Newman structure. Here you will have CH3, hydrogen, 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 CH2Cl. So both the structures have same molecular formula, C4, count 1, 2, 3, 4, C4H9Cl, and these are isomers. However, the two half groups, that is the methyl and the chloromethane part, can you see this methyl and this chloromethane part? They are neither enantiomers nor diastereomers. Hence, these are structural isomers. C will be the answer for this question number 17. Let's see question number 18. Which of the following compounds exhibits geometrical isomerism? So, formula for this compound, let us write down the possible. A will not give geometrical isomerism, nor C. Let us see B and D. If I rewrite the structure of this acid, it will now be in this form, double bond CH COOH. So this can have geometrical isomerism, cis and trans. Whereas in the remaining three, there is no possibility of writing the geometrical isomerism cis and trans. Question number 19. Chlorine in vinyl chloride is less reactive because, see, you write the resonating structure and you will understand this part. If I write the resonating structure of this, chlorine will have 3 lone pair because these are the bond electrons which does not participate in bonding. After resonance, this structure will behave and it becomes a positive charge. A double bond is formed between carbon and chlorine. Hence, it is less reactive due to resonance. Okay. Question number 20. The best method for the separation of naphthalene and benzoic acid from their mixture is. See, among the given compounds, naphthalene is volatile, but benzoic acid is non-volatile because it forms dimerization and forms dimer. So the best method for their separation it may be by sublimation. Okay, so which is more applicable? Let us see. So applicable to compounds which can be converted directly from the solid to the vapor phase or vapor to the solid. This is your sublimation method. So which is the most appropriate answer for this question? The best method for the separation of naphthalene and benzoic acid from their mixture. So the best method must be sublimation. You know why? The compound naphthalene is volatile, but benzoic acid is it undergoes dimerization. You keep this naphthalene balls for 1 month, it will disappear. You know why? Yes. Question number 21. The percentage of sulfur in an organic compound whose weight is 0.32 is given. It produces 0.233 gram of barium sulfate. You are given the atomic mass of barium and sulfur. So how to find? Initially, we have done the percentage finding of phosphorus. So carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, their percentage calculations are important. So you have to remember their formulas. And for sulfur, the percentage can be calculated by using this general formula. Okay, divided by given weight is 0.32 into 100. So you can easily cancel this, right, by how much? 100. And this you can cancel by 1000. Cancel this. You have 1, 10. 10 is the answer. Good. Question number 22. Read the question. Indicate the wrongly named compound. This is from nomenclature part. Very simple. So D, I think this is the incorrect because where is the question? The screen shrinks. Okay, we are back. Indicate the wrongly named compound. When you do the counting from the left side, right side to the left side, 1, 2, 3, 4, 5, 6. This becomes hex 3 in 2 on. This is the incorrect. Question number 23. The R and S enantiomers of an optically active compound differ in. So their optical rotation of plane polarized light. They differ in with respect to optical rotation of plane polarized light. Option B. Question 24. Butene exhibits cis-trans isomerism due to restriction around carbon-carbon double bond. Which of the following compound exhibits or undergoes nucleophilic substitution reaction most easily? You have to find the compounds that undergoes SN reaction. So in SN reactions, a carbonyl is formed as an intermediate. So any substituent in that particular case increases the stability of carbon ion and hence the transition state leading to its formation. It will enhance the SN reactions. So to compare the rate of substitution in chlorobenzene having EWG, I would call it EWG, also known as electron withdrawing group, and chlorobenzene having ERG or electron releasing group. So when we compare the structures of carbon ion, this carbon ion 1 from chlorobenzene, I'll call it chlorobenzene carbon ion, and 2 from chlorobenzene containing electron withdrawing group, and 3, let me call it here 3, from chlorobenzene containing ERG, this is ERG, you can find that this it activates the SN reaction. In the case of nitro is an activating group, whereas methyl and methoxy, they are deactivating group towards nucleophilic aromatic substitution reaction. So make the ranking, the most stable will be this nitro containing compound. I'll write here 1, okay. The second ranking will be this chlorobenzene. Third will be this para mixture containing methyl, and the last one will be this option C. So A, D, B, C is the sequence. So the most reactive or the compound that undergoes nucleophilic substitution reaction most easily will be A. So A will be the answer for this question. Question number 26. An organic compound given to you, carbon percentage is 40, hydrogen is 13.33, nitrogen is 46.67. Its empirical formula would be, so as in the above question, you have carbon weight by atomic mass gives you percentage 3.33. Hydrogen will be 13.33. Atomic mass of hydrogen is 1. So 13.33. Nitrogen will be, the given mass is 46.67 divided by 14, 3.34. So the relative number of atoms will be You have to divide by the simplest. You have to find the simplest whole number ratio. So carbon will be, see, the most minimum number, that's 3.33. Divide by this number in all the cases. You get 1. And for hydrogen, you find the rough estimate. No need to calculate exact value. So how much time? 3 fours are 12. Nearly 4, let us say. Nitrogen is 3.34. 1 by, so 3.33. You're dividing all by the least number. So it gives a simple whole number ratio 1. So it must be CH4. This is the empirical formula of the question. Okay, option C. Question number 27. The name, IUPAC name of the given organic compound is, you write the, do the numbering 1, 2, 3 according to the priority. Functional group is the most priority. It gets the lowest number. So it becomes 1 hydroxy 4 methyl 3 pentanone. So A is the answer for this question number 27. Clear? Good. 28. An important chemical method to resolve a racemic mixture makes use of the formation of the following. Diastereomers, remember, have different solubility in melting point and boiling point. Hence, they can be separated by crystallization. So, important compound or important chemical method to resolve a racemic mixture that makes the use of the formation of this compound will be C. Let's see question number 29. The lysines extract is boiled with dilute nitric acid before testing for halogens because, yes, it will be, see, remember the lysines extract preparation. Sodium sulfide and sodium cyanide that is formed during the fusion with the metallic sodium must be removed before adding silver nitrate. Otherwise, the black precipitate due to sodium sulfide or the white precipitate due to silver cyanide will be formed, and thus white precipitate of silver chloride will not be easily identified. Right? So the answer for this question will be option B. Sodium sulfide and cyanide are decomposed by nitric acid. Question 30. What is the decreasing order of the strength of the base hydroxide amide? 30. Stronger the base, the acid, weaker the conjugate base. Weaker the conjugate base, stronger the acid. Or weaker the acid, stronger is the conjugate base. That you have learned in equilibrium part, acid and base part. So the acidic character follows water, ammonia, alkyne, then alkane. Okay, alkene and alkyne hydrocarbon part. You go back and refer to the previous episode of hydrocarbon. There I have explained that sp and sp2, which one is more acidic, which one is less acidic. The basic character of the conjugate bases will now decreases. See, the acid character will follow this strain. Stronger the acid, weaker is the conjugate base that I have explained, right? So this is the acidic strength or the acidic character will follow this. What about the base character? It will follow the one after losing the hydrogen, it becomes a conjugate base. Okay. So triple bond hydrogen, it goes and keeps on decreasing in this tree because water, which was initially the strongest, now it becomes as the weakest conjugate base. So answer for question number 30 will be, compare and tell the answer. It is 30A. I hope you're keeping up. We are left with only 15 questions. You should be consistent to be successful in life. Given to you, which of the four given compounds can exhibit tautomerism? You have to check whether there is any alpha hydrogen present, right? So 1, 2, and 3 all have. So it all can undergo tautomerism. Question number 32. See, question number 32. Cyclohexanol Acetic acid, you're given in terms of order 1, 2, 3, 4. Okay. 2,4,6 trinitrophenol, phenol. Which of the following is a decreasing acidic character? Presence of three nitro groups in orthopara position to phenolic groups in this option number 3, that is 2,4,6 trinitrophenol, will make phenol strongly acidic because its corresponding conjugate base is highly stabilized due to resonance. Conjugate base of acetic acid, acetate, is resonance hybrid of two equivalent structures. The conjugate base of phenol 4 is stabilized due to resonance. Remember, all the resonating structures are not equivalent. Okay, the conjugate base of cyclohexanol 1 does not exhibit resonance, hence it is not formed. That means when you do the order, the first one, as I have told you, because of the presence of 3 nitro group, 3 comes first, followed by acetic acid, then phenol, then cyclohexanol. So 3, 2, 4, 1 will be A. Question number 33. Some meta-directing substituents in aromatic substitution are given. Which is the most deactivating? The decreasing order of deactivating effect of the given meta-directing group will follow according to this given options. Nitro followed by nitro will be the first, followed by cyanide, sulfonic acid, then carboxylic acid. Nitro group is most deactivating. You should know that it is due to the strong minus E effect, minus I effect, minus M effect. So C, the first one, nitro group, is the answer for this question. Let's move to question number 34. Consider thiol anion and alkoxy anion. Which of the following statement is correct? So on moving down the group, the basicity and nucleophilicity are inversely related. That is, nucleophilicity increases while basicity decreases. And thiol ion is more nucleophilic but less basic than alkoxide ion. So what happens? This opposite behavior, it is due to the fact that basicity and nucleophilicity depends upon different factors, right? So basicity is directly related to the strength of the hydrogen element bond, while nucleophilicity is indirectly, or you can say inversely related to the electronegativity of the atom to which the proton is attached. So the ion coming from thiol, Rs minus, will be less basic, more electrophilic than the alkoxide. See question number 35. Consider the following compounds. The correct decreasing order of their reactivity towards the hydrolysis. Right? So how to answer this? Now note that the degree of hydrolysis increase as the magnitude of positive charge on the carbonyl group increases. Okay, an electron withdrawing group increases the positive charge and electron releasing group decreases the positive charge. So among this nitro and this aldehyde group, there are electron withdrawing group, from which the nitro group has more minus I effect, that is electron uh, taking. Okay, plus will be electron giving. So then the aldehyde group. On the other hand, the methyl is an electron releasing group. We call it ERG, right? Initially we have done that before. Therefore, the order of reactivity towards the hydrolysis will first follow. I will write it here. It will follow this sequence. COCl. Then you have your nitro group. Do the comparison and answer the question. Now you have the carbonyl group. Acid halide. This substituent is your benzene. Then COCl. You have this group. So answer for this will be 2413. C is the answer for this question 35. The order of stability of the following tautomeric compounds will be: enolic form will predominate in compounds containing two carbonyl groups separated by a CH2 group. This is due to the following factor. Factor number 1 is presence of conjugation, which increases the stability, and formation of intramolecular hydrogen bond between the enolic hydroxyl group and second carbonyl group, which leads to the stabilization of the molecule. Hence, the correct sequence will be 3, 2, 1. So A is the answer for question number 36. Let's see, match the column. Dumas method, Geldar's method, Carrier's method, phosphorus detection, question number 37. So let us do the matching. A match pass for, this is for nitrogen, okay? Dumas is for nitrogen. B, Geldar's method, remember, this is for volume and molality. C, molality, percentage of phosphorus. We have done this before, right? So answer is A. A4, B3, C1, D2. 38. Which of the following represents the correct order of stability of the carbocations? Minus I group destabilizes carbocation and since inductive effect decreases with increasing length of carbon chain. Therefore, option B is the correct answer. 39. This is a quaternary salt. It's neither an electrophile nor a nucleophile because the octet around nitrogen is incomplete. Okay, how many electrons? We have 7 electrons. It is incomplete. Neither an electrophile nor, okay, sorry, it was, okay, we have seen here how many nitrogen. You can write this 4 methyl group and a positive charge. So we have to say it is complete. Hence, no electrophilic character is going to be present. And nitrogen has no unshared pair of electron to act as nucleophile. So B is the answer. Neither it has electron pair available for donation nor can accommodate electrons since all the cells of nitrogen are fully occupied. Good. Now we're left with only 6 questions. Let us see. Continue. In the Geldar's method for the estimation of nitrogen, potassium sulfate and copper sulfate are used. On the basis of their functions, which of the following statements are correct? Given options are A, B, C, D. In statement 1, potassium sulfate raises the boiling point and ensures complete reaction. Copper sulfate acts as catalyst. Potassium sulfate acts as catalyst and copper sulfate raises the boiling point. So note here that the catalyst is your copper sulfate and the one that is going to raise the boiling point is your potassium sulfate. So 1 and 2 are correct. B will be the answer for question number 2, not 3, okay? Potassium sulfate is not catalyst. Next, question number 41. What is the relation between open chain form of D-glucose and D-altrose? So the constitutional isomers for this will be, you can write the structure of altrose, carbon, hydrogen, and OH group. This is oxygen, okay? And here you have CH, polyhydroxy, trihydroxy. Now you have the phenolic group, the alcoholic group. Glucose, you can now elaborate the structure which according to the Fischer. If OH is present on the right side, we call it the alpha form. Then C2OH2, then C2OH. Right, so these are the constitutional isomers. The production of an optically active compound from a symmetric molecule without resolution is termed as, this is called asymmetric synthesis. 43. The number of asymmetric carbon atom created and the number of possible isomers when benzyl is reduced with lithium aluminum hydride. Benzyl, when it is made to undergo reaction with lithium aluminum hydride, it forms inactive, optically inactive mesoform. So must be a hydroxy group H. So the product contains two similar asymmetric carbon atom and two optically active and one optically inactive meso compound. So do 2 and 3. Number of asymmetric carbon will be 2 and number of possible stereoisomers will be 3. Question number 44. Among the following, the true property about this carbocation is. See, in carbocation, carbon bearing positive charge is always sp2. I will give you the formula for finding hybridization. Half valence electron monovalent minus cation charge plus anion charge. And always carbocation will be sp2. Okay, answer will be B. As usual, the last question is left for you to answer. Tell me the answer in the comment section. And I'm going to meet you all in the next episode. Happy learning and stay consistent. Thank you.